on the paper I'm holding. Go ahead. Hi scientists. We've been exploring pendulums and trying to change different things about the pendulum to see if it will affect how many cycles we can get. Now is the time for you to take out that lab sheet that you got, and you're going to be recording and filling this out along with us. We thought we should try changing the length of the pendulum to explore the effect that that has. How could we write that as a testable question? We could write, will changing the length of the pendulum affect the number of cycles in 15 seconds? So make sure to write your testable question in here as well.
Now that we have our testable question, we need to identify the variables that we're changing and observing. So in that question, what is our independent variable and what is our dependent variable? Our independent variable is what we're changing, and that would be the length of our pendulum. Our dependent variable, what we're observing or measuring, is our number of cycles.
In addition to the independent variable and dependent variable, we also need controlled variables. These are the variables that we try to keep exactly the same from trial to trial so that they don't affect our results. Let's think back to our standard and everything that we use to describe what our standard pendulum should be like. Those are the things that we want to keep the same as we change the length. So some of the things that we want to keep the same are the bob. We want the exact same mass of the bob each time. We also want to make sure to release the pendulum from the exact same spot each time. So the point of release. We want to count cycles for the exact same amount of time for each trial. So amount of time. And we want to count cycles in the same way, back and forth. If we counted in a different way each time, then we wouldn't be able to understand our data. Make sure to add your control variables to your list as well.
Our next step is to take our testable question and turn it into a hypothesis. Since we've been exploring pendulums for the last several class periods, we do have some good background knowledge. Think back to what happened when Ms. Knight and Mr. Beachy tried to change the point of release and when they tried to change the bob. And we gathered some really good information from those two experiments. So based on that and maybe some of our own prior knowledge, what do you think is going to happen when we change the length? I would like you to record your if-then hypothesis on your lab sheet. The hypothesis we came up with is, if we change the length of the pendulum, then the number of cycles in 15 seconds will be affected.
All right, we are now going to get to the part where we get to collect data. We're going to use these lengths as we change the length of our pendulum. So go ahead and write on your lab sheet 170, 90, 55, 22, and 18.
Reference the standards again, like what you're controlling as you.
All right, so I am starting with my 170 centimeter pendulum. I want to remember those controlled variables. I've got a penny for my bob. I'm going to make sure to use the same point of release, a perfect 90-degree we're gonna set a timer for 15 seconds, and we're gonna kind of cycle as when this bob travels all the way away and back to me. When it comes to me, that's 1. So we're gonna do 3 trials with this length.
I'm setting the timer.
I'm ready.
Set, go.
For that first time I got 6. It didn't make it all the way to 7, so just 6. Let's try again.
Trial 2, ready. I'm gonna go up a little bit there. There you go. Set, go.
That time I let it go a little bit late and I only got 5. What should I do?
In a situation like that, that's why we have a spot in our journal where we can record notes. So we would just want to document that we released too late on that trial, and then we'll know that those results might not be accurate.
Okay, thank you. Do one more
We could
time.
always do extra trials if we had the time or wanted to. That way we had more data to compare. Okay, but we're going to keep going on here to trial 3. Ready, set, go. We're going to change our pendulum out now. This time we're going to be recording for 90 centimeters.
I've got my 90 centimeter pendulum ready.
Timer set, go. Trial 2, ready, set, go. Trial 3, ready, set, go. Okay, now we're ready to go on to 55 centimeters.
All right, my 55 centimeter pendulum is ready.
Set, go. Trial 2, ready, set, go. Trial 3, ready, set, go.
22 centimeters.
Ready, set, go. And notice on that one, the cycle started to almost rotate instead of a back and forth motion. That's okay, you still want to count a full circle as a cycle here. So because of the length, it is changing direction slightly. Trial 2, ready, set, go. Trial 3, ready, set, go. We could even on our data table in our notes section comment on the fact that those cycles started to rotate in a different direction, making those observations along the way. And our final pendulum, we are at 18 centimeters. Trial 1, ready, set, go. Trial 2, ready, set, go. Trial 3, ready, set, go. Weren't they? I didn't notice them like being crazy off.
I was getting some 19.
Do you want to change?
Is it okay if we average 17?
Okay. Now I'm explaining how we,
Right, get the average.
and we would pause the, like we don't have to say anything now, we would pause the video, right, at that point, and they would,
And there would be a note
note
that
saying
says,
like change
catch up
your
your lunch.
data or whatever. Right, now that we have our data, we need to find our averages for our trials. To find average in math class or mean, we would add these three numbers together and then divide by 3 because we did 3 trials. Lucky for us, our data is pretty consistent, so we can look at which number occurs most often. And remember, we had some notes also, so for trial 2 here at 170, Mrs. Morrison recognized that she didn't release quite on time, and so that might be why our 5 is not an accurate piece of data here to begin with. If you have a number that's really far off because of something that you noted that maybe went wrong, maybe you're doing it and your pendulum hits something, you don't want to include that data at all in your average. Lucky for us, that did not happen. So we're going to kind of look down through here. We have 6 occurring most often, so we would say 6 is our average. We had 8 across the board here, 10, 16, and then again here we had some varying numbers, but 19 appeared to be the number that occurred most often. Okay? And now we have this great data that we can look at to analyze and figure out what the relationship is.
All right, on the back of your lab sheet is a secret question. This question is asking us, did changing the length affect the number of cycles that we got every 15 seconds? And another way to ask this question is, what is the relationship between the independent variable and the dependent variable? Let's look back at our data. Remember, our independent variable is what we change as the experimenter, and we change the length every time we chose a shorter and shorter length. The dependent variable is what we observed that was affected by the independent variable, and that is going to be our average cycles per 15 seconds. So we can notice as our lengths went down and got smaller, it looks like the number of cycles that we got every 15 seconds got bigger and bigger and bigger. By observing that, once we've collected and organized all of our data, we can make a statement. We can make a conclusion about what we are observing with our data. So you take a second and think, what do you notice is happening? What is that relationship between the independent variable and the dependent variable? And the way I put it is, the longer the pendulum, the fewer the number of cycles we got every 15 seconds. So as our pendulums got longer and longer, it was moving more slowly and we got fewer cycles each time.
Now, Mrs. Morrissey, could I also say that the shorter the pendulum, the greater the number of cycles in 15 seconds?
Absolutely. That's still comparing the independent variable to the dependent variable.
Okay. Yeah, so oftentimes we can state that relationship in more than one way. So next week, we're going to take our information from our lab, our data. We're going to continue to analyze it a little bit further. We're going to draw some conclusions, and then we're going to communicate to the world what we have discovered. And we're going to do that with the help of some graphs. So look out for that next week. Great job today.